Всем привет. Поговорим про нейросети.
Okay, let's speak about neural networks and how neural networks are related to cybersecurity. Without long introductions and about myself, I will tell you one story. Last winter, I've received in Telegram, please put the word Rabotakula in the... And what I've seen myself in the Google through the word Rabotakula, the phrase which means nothing. For 1 year, I've been there. Right now, you won't be able to find me because it was a landing to open a day. But I was really surprised. How was I in Google through this interesting request? And honestly, if you will look at this picture, that was the first one in Google production. And if you will bring a certain sector closer, you will see that there is a sticker from Ozone which says Rabotakula. And what happened? The Google algorithm found this phrase on my picture. They are very cool, and neural networks which are available inside of, they've analyzed it, they found this phrase, and they started associating me with it. So the breakage of the Google happened because I shouldn't be in this phrase. There should be something else and something different, and I would be associated with it. But it pushed me to the idea that neural networks are very cool from the performance point of view, from the point of view of how they're changing our life. But there is something inside of them which adds risk to some business applications. And right now I'm going to tell you about 3 cases of what can go wrong if you will implement neural networks in real life without proper care and business sense. Okay, let's begin with the case number 1. I will tell you about 3 ways of breaking neural networks. Let's begin with a simple one. With artificial breaking when we didn't want, but we broke something. And in order to explain it, I will tell you how these networks and other AI or ML algorithms are working. The main principle is following. All the machine learning is a way of finding a very precise patterns in historical data. We are looking at how people have been looking at YouTube. We see patterns on YouTube, we analyze them, and we try to learn to predict them. And YouTube algorithms can tell you which video you will like, which video you will not like. And they do it very simply. They look at what you've been looking previously, what other people similar like you've been looking before, and they come to their own conclusions. Same in the banks. When you come to the bank and when you apply for the loan, bank analyzes the past of your profile, and your profile is connected to another one, and they predict the probability will you return this loan or not. So the whole artificial intelligence, ChatGPT, and other methods that you face in your life, they are actually based on this simple paradigm, very careful analysis of historical data and application of these patterns for the future. So here's another example of other things. I will start with a quote, which in the year 2016, which was 10 years ago, was sent by Jeff Hinton, the artificial intelligence winner and one of the greatest researchers in this area. He said that we should stop training radiologists, so that people who are doing radiologists, who look at the radiology images and do the diagnosis. In the year 2016, he said we should stop training them because very soon deep learning will replace all of them. You will be surprised or not surprised, but starting 2016, the number of radiologists have grown. The number of students who study for this specialty has grown, and the deficit of these people has grown. Why it happens and why deep learning was not able to replace radiologists? Because reality is the following. We can take data from real hospital, from any hospital in Moscow, and we can look at the radiology pictures, which diagnoses were given by the doctors. We can teach our model on the basis of this data. We can evaluate this model on the other part of this data and see that everything is very cool. Neural networks can give diagnosis not worse than people. But as soon as we implement this model as the doctor's assistant or as a replacement of the doctor, we can see a problem. And one of the illustrations of this problem on this slide, you can see diagnosis that was given by the neural network and a picture which brings them to this assumption. It's surprising, but in real experiment that was conducted by a scientist, it happened that neural network that was learned on radiology pictures has learned not to diagnose them, but to define notes that was made by the doctor, because it works after the doctor worked on these neural networks. And sometimes doctors point those information or other points, and neural network didn't learn to define the level of making diagnosis, but just learned to define those notes that were made by the doctor. And there's a lot of cases like that. Neural network has learned to find the model of scanner and by this make a diagnosis. If it's a mobile scanner, it was brought to the patient, then it's a heavy patient and some big problem. If it's a stationary and the patient just enter with his own feet, then there's less problems and it's not such heavy. So neural networks, they cannot understand our logic and go deep into the business content, but they follow on the superficial things and which are related. And neural network has learned to define the notes by doctors, and it doesn't help doctors because these notes are made by the doctors. This is the first example how the neural network can be broken, just unexpected, without even this purpose. The second example, attacks against neural networks. Simply speaking, this cybersecurity forum, we all speak about attacks, but very often we speak about attacks against infrastructure to steal a password or to make DDoS attack or to obfuscate some data. But what does it mean to attack neural network? Well, neural network can be attacked without knowing about artificial intelligence or anything. Here's a simple example. The pattern is very simple. Neural networks analyze historical data and apply these patterns which have been discovered on these historical data, new cases which come to them. And here's an example from the Upwork. Upwork is a freelance platform where you can put resume and get tasks. And from Max Planck Institute, colleagues have made an experiment. They put a design objective and they downloaded resume of a designer with a unique symbol. There was a unique symbol with the resume which you cannot see in any other resume. And then this resume was hired for their objective. They gave very high numbers. You shouldn't be expert to do things like that. And they did it several times. So, and about 100 resumes went through this cycle was enough to lie to the Upwork, and your resume with the secret symbol would become the top for the design. So when a new client comes who doesn't know about the scheme, and he sees you're a very cool designer, your resume is in top, you received good numbers, and you should be hired. But you may not be even a designer. You are a person who figured out that in resume you have to put this secret symbol, which you have to click it yourself, and you have to lie to the neural networks. And this example is not only about Upwork, but you can Google and you can find cases with Uber drivers. Uber drivers are very smart people. They are united in chats. They agree that drivers have to come to one place, close to Luzhniki, for example. And drivers come to Luzhniki. And what happens? Algorithm of Uber understands, well, here's an overload of drivers, and we shouldn't send any more drivers down there. And only these 100 drivers stay here. Then these drivers, at a certain moment of time, they switch off their mobile phones at a certain moment of time. What Uber understands that there is no taxi drivers around Uber, and prices are going up, and we have higher prices, and everything is very expensive. In 10 minutes, these drivers switch on their phones once again. They take these client orders for higher price, and that's how they manipulate pricing algorithm, which is based on machine learning, in order to earn money and to break a system. That's why, in this sense, neural networks are more fragile than our standard rules that we can say we don't sell cigarettes for people below 18 years old. But those rules which are based on thin pattern analysis, they are even more fragile and they can easily be broken. And the final one is very complicated. It's something that requires special skill set, mathematical preparation, and deep understanding of methods. This is about complicated neural network attacks, and they are very complicated in explanation. In 20 minutes, I will not be able to do them, but I would like to show you something about them. Let's look at this picture, and in this picture, you can see there's a pig, hog. And if you'll take a modern neural network which classifies images as us, it will say that it's a hog. Well, everything's wonderful. Neural networks are very good, and they classify these images much better than we do it. However, what is surprising, I can write about 10 lines of code, very simple code in Google Colab without any special means, and I can find this noise. This noise means nothing to you. This is some kind of noise, some kind of pixels for you, which are brighter or darker, and for this illustration, I have increased it 50 times. But this is a very small noise, and if I will add it to this picture, for us, this noise will stay a pig. We will not be light. We see that this is a noise, but for the neural network, it will become an airplane, and it's very surprising. Well, we took a very powerful neural network, which is one of the best, and 10 lines of code is enough to lie to the neural network without lying to people. What consequence can be? Very serious consequences. Here's an example of ideal article. The authors are typing glasses on 3D printer, which allows them to lie to neural network which recognizes faces. And author printed this face, and from the point of a neural network, he became a well-known actress. And can you imagine your bank account or your iPhone, who can also potentially be broken through the neural network? Another example is self-driving cars. And if you will get outside of Luzhniki, you will see several Yandex cars which are driving and constantly learning. So the same same way, we can invent special patches for the road signs, and from the machine point of view, the stop will become speed limit 45 miles, which is 60 kilometers an hour. So instead of stopping, the car will drive through this place and possibly will lead to the accident. So neural networks are very fragile things which can be attacked in such a way. It's not very simple to do it, because I'm a little bit exaggerating to make such an attack. You should have a neural network on your computer. If you don't know which neural network is used by Apple, but it adds risks to those people who follow the security, because if we want for our neural networks in business to be protected and wouldn't allow the attacks, we have to be very careful from the point of view of how we're training them, what we're telling people about it, because we always want to post our neural network, put it open source to give it to the community for the check, and we always have to follow that our neural networks would be protected from the directed attacks, and as in the last example, and from the attacks which are made by people who constantly are trying to cooperate with services, who constantly try to see where this ML can be broken and allow itself to be exploited. So that's the example that artificial intelligence brings a lot of new opportunities, and that's true. We all are, are amazed how ChatGPT is working, language Yandex models or SBR, but risks are coming together with it, and these risks are challenges for cybersecurity specialists, because we have used to historically working with determined algorithm systems where the whole code is written, where we know input and output of the data, and we know how to protect them. But right now in the business, there's more and more of such determined systems which are replaced by artificial intelligence systems which are adapted to the situation, develop themselves, and protecting them becomes more and more difficult. That's why my advice to you as a current or future cybersecurity specialist, don't limit your spectrum of technologies. Don't look narrowly at cybersecurity, but look at the whole context and extend your skill set, including by methods of artificial intelligence. And by the way, with this approach, we are building university. And I'm a product director in a central university. There's a central university stand where people are going through the selection to our program, postgraduate program, and we are making university in such a way so that our guys wouldn't be a narrow specialist in artificial intelligence, cybersecurity, development, or something else, but people who are wider specialists, who know something very deep but have a very wide context. And our cybersecurity specialists should know, and those people who develop systems on the basis of artificial intelligence, they know cybersecurity and they know how to make it secure. Thank you very much. It was very interesting.